we did two of these examples. A particle moves in a straight line such that its displacement as meters from a fixed point O on the line at time t seconds is given by this. So equation of work to example 3, equation of displacement is given, that is 20 e raised to power minus 2t minus e raised to power minus 3t. Find the value of t when the particle is instantaneously at rest. So if it is at rest, velocity is 0. And the order was displacement time, velocity time, acceleration time. To get velocity, we have to differentiate the equation of displacement. That is, constant stays out, differentiation is once as it is, and into the differentiation of power. And once as it is, into the differentiation of power. E is equal to 20, that's minus 2 e raised to power minus 2t, minus minus plus 3 e raised to power minus 3t. And when it is at rest, v is 0, 20 divided by 0 divided by 20, and we're left with minus 2 e raised to power minus 2t plus 3 e raised to power 3t. Now this is 0, 2 comes on this side, gets positive. This was minus 3. I'm dividing e raised to power 3t on left hand side. E raised to power minus 2t over e raised to power minus 3t is equals to 3 by 2. Basis same, powers subtract in division. Minus 2t minus minus 3t is equals to 3 by 2. So left with e raised to power t is equal to 3 by 2. Applying ln on both sides, t is equals to ln 3 by 2. 0.405 seconds. B part says the displacement of the particle from O when t is equals to 1. Displacement of particle when t is 1. So we already have the equation of displacement. This is not the distance, that's displacement. So we simply substitute. S is equals to 20 e raised to power minus 2t minus e raised to power minus 3t. The 20 e raised to power, when you substitute 1, we get minus 2 minus e raised to power minus 3. And using calculator, 20 into e raised to power minus 2 minus e raised to power minus 3. This is 1.71 meters. C part says find the total distance traveled during the first second of motion, total distance. Now understand that if the particle started from O and instantaneous speed was 0 at 0.405 seconds, that means the particle is changing direction at 405 seconds, not after that, not before that. So I need the displacement at 405 as well. So first I'll check at 0. Displacement when time is 0. So e raised to power 0 minus e raised to power 0 when t is 0. That's 1 minus 1, 0. So displacement is 0. So at time t is equal to 0, it is at origin. And then when time is 0.405, displacement is 20 e raised to power minus 2. I'll use the exact value. That was ln 3 by 2. ln 3 by 2 minus e raised to power minus 3 ln 3 by 2. I'm punching this in calculator. 20 bracket e raised to the power minus 2 into ln 1.5 minus e raised to the power minus 3 into ln 1.5. I'm getting exact 80 by 27, which is approximately, just for idea, that is 2.96. So I'm bringing that down. At 0, it was at origin at 0.45. This is at 2.96 something, and this is 1.71. At time 1, it is at 1.71, so it is coming back. This position is 1.7 meters away from the origin. So basically, particle traveled 2.96 meters in the first 0.4 seconds, and then this is the distance it is covering, because it is at this position when time is 1 second. So I need to find this, which will be the difference of both of these values. 2.96 minus 1.71. 2.96 plus 2.96 minus 1.71 gives us 4.21 meter. Check. 4.21 meter, yes. Any doubts?
No.
Okay. Work example 4. A particle travels in a straight line so that t seconds after passing through the fixed point O, its velocity is this. Now, equation of velocity is there. Find the value of t when particle first comes to instantaneous rest. So velocity at that point is 0. So when velocity is 0, we can equate this equation with 0. Pi goes divides. Cos inverse of 0 is pi by 2. 2 goes there. And t is equals to pi. So at time, t is equals to pi. And then it says find the acceleration when the particle acceleration. So displacement time, velocity time, acceleration time. So that is derivation. So we derivate this differentiation of cos is minus sign and divide with the differentiation of angle, that is 1 by 2. So pi by 2 minus 5 by 2 sine t by 2, and you just substitute pi and get the value. Practice exercise. Exercise 16.1. Question number 1. A particle moving in straight line through fixed point O. Its velocity v meters per second after passing origin is given by this equation. V is equals to 50 into 3t plus 2 raised to the power minus 2. Find the velocity of the particle as it passes through origin. So when it passes through origin, time at that point is 0. 50 into 3 to 0 plus 2 raised to the power minus 2 is 50, and that's 1 by 4. So 50 by 4 is 12.5. 12.5 meters per second. B part. Find the value of t when the velocity is this. Now velocity is given 0.125, 50, the t, or let's just use the other side, that would be easier. So dt plus 2 raised to power 2. I'm cross multiplying. 3t plus 2 raised to power 2 is equals to 50 over 0.125. 50 divided by 0.125 is 400. 3t plus 2 whole square is equals to 400. Square root both sides. 3t plus 2 is equals to 20. We're not writing negative number because time is not negative. 3t is equals to 18. T is equals to 6 seconds. And the last one, find the acceleration of the particle when t is 1. So SBA, you have to derivate that. Velocity is 50 into 3t plus 2 raised to power minus 2. So acceleration is dv by dt, differentiation. So power comes down, gets multiplied, minus 100. 3t plus 2 power minus 1 into the differentiation of base, that's 3 in this case. So minus 300 over 3t plus 2 raised to power 3. And time is 1. So minus 300 over 3 into 1 plus 2 whole cube. That's 5 minus 300, 125, and 300 divided by 125 is 2.4, negative 2.4 meters per second square. Let me check these answers. 16.1, question 1. 12.56 and minus 2.4. Try question number 2.
2, right?
Question 2.
Initial velocity is 6 meters per second, and initial acceleration is 10 meters per second squared.
Question 2. 6 and 10 both are correct. Okay. Number 3. A particle starts from rest and moves in straight line so that t second after passing through fixed point O, its velocity is given by this equation. And the velocity of the particle when time is this. Question number 3, v is equals to phi 1 minus e raised to power minus t. V is equals to 5, 1 minus e, and what time is ln 100. So that's simple substitution. 5 bracket 1 minus e power negative ln 100, bracket closed, and I'm getting 4.95 meters per second. Second part says state the value of v which v approaches as t becomes very large. Okay, when t becomes very large. So basically, v is equals to 5 to 1. See that power is negative. I can write it like this. Now assume when t becomes very large, this denominator actually becomes very large, which it reduces this overall fraction, and 1 almost approaches 0. So 5 into 1 minus a very small value. So v would approach, state the value v. So v approaches 5. C part. Find the acceleration of the particle when v is 4. Differentiation of velocity will give us acceleration. V equals 5 into 1 minus e raised to power minus t. Acceleration is dv by dt. And 5 stays there, constant disappears. And we have once as it is and into the differentiation of power. So that's 5 into 0, that disappears, minus minus plus 5 e raised to power minus t. And find the acceleration of the particle when v is 4. This is the equation for acceleration, and when v is 4, I need the time. V equals 5, 1 minus e raised to power minus t. When this is 4, so 4 by 5 equals 1 minus e raised to power minus t. This comes on left hand side, e raised to power minus t is equals to 1 minus 4 by 5. 1 minus 4 by 5 is 1 by 5. E raised to power minus t is 1 by 5. And 1 over e raised to power t equals 1 by 5. Cross multiplying, and t is equals to ln 5. So when t is ln 5, acceleration is 5 e raised to the power minus ln 5. That is 1. The acceleration is 1 at that time. Four point nine five, 5 and 1. D part. Sketch the velocity time graph for the motion of the particle. So basically, velocity time graph. Equation of velocity is 5, 1 minus e raised to power minus t. So this is 5 minus 5 over e raised to power t. When t is 0, when time is 0, so that's 5 minus 5, 1. 5 minus 5, 0. And when t keeps increasing, this fraction keeps on decreasing. So we get curve which would approach 5, approaches 5 and time continues, and yes. Any doubt? No doubts?
Sorry?
Any doubts?
No.
Okay. Let's just skim and scan. Particle moves in the straight line. Displacement from fixed point to O is given by this value. Displacement is this. Final velocity. Show that the particle decelerates. Question 4 is good. Try this.
Can you hear me?
I can.
Okay. Okay, now the voice is a bit clearer. Okay. I'm doing question 4, right?
Yes.
Okay, so for A and B part, it's time. So in time, when displacement is 36, would be E4 minus 2 over 3. And then velocity at t equals 1 would be 27 over 5 meters per second. And then for the last part, it would just, like, we would have to draw it out. So it would be it would just show that the particle is decelerating for t because acceleration is always negative.
That's Question number 5. Particle moves in a straight line so that t seconds after passing through a fixed point O, its displacement is given by this equation. Find the value of t when the velocity of the particle is 0.4. So displacement is ln 1 plus 2t. Velocity would be differentiation. So that's 1 over 1 plus 2t into 2. When the velocity is 0.4, we cross multiply. 1 plus 2t is equals to 2 by 0.4. That's 5. 1 plus 2t is equals to 5. 2t is equals to 4. T is equals to 2. Find the distance traveled by the particle during the third second. The displacement distance traveled, displacement at time 2 and time 3. But I also need to check if the particle is turning back or not. So equation of velocity is 2 over 1 plus 2t. And it's not turning back because when I substitute 0, I will not get value of t. So it is moving in straight line. So time in third second is directly displacement in 3 and displacement in 2. So that would be ln 1 plus 2 into 3 minus ln 1 plus 2 into 2. Ln 7 minus ln 5. ln 7 minus ln 5 is 0.336. Find the acceleration of the particle when time is this. So we already have the equation for velocity. I'm copying that. Velocity is equals to 2, 1 plus 2t raised to the power minus 1. And acceleration is differentiation of velocity minus 2, 1 plus 2t raised to the power minus 2 into 2. This will be minus 4 over 1 plus 2t squared. Time is 1.5. 1 plus 2 into 1.5 squared. 2 into 1.5 is 3. 3 plus 1 is 4. 4 squared is 16. Minus 4 over 16 is minus 1 by 4 on negative 0.25 meters per second square. This was question 5. Time 2, then 7 by 5. That is it. Just use calculator. This was ln7 subtraction and then negative 0.25. 6 has that graph. Let's try 6 and 12. Then we move on to next exercise. Try number 6.
So for a part, it should be, so when velocity is 4 meters per second, it should be 4 pi over 3 seconds.
6a 4 pi by 3 is correct.
Yep, and then I'll do B part. So then the acceleration at t equals 5 is around 1.955 meters over a second squared.
1.9 is correct.
Okay. And then for the graph, I'll just give the
Graph of
intersection.
acceleration. So we'll have the equation of derivative of velocity and then draw the graph. I think you already have the equation. Differentiation of cos is minus sine into differentiation of angle. So minus 2 sine t by 4. We sketch this. Amplitude is 2 because of negative sign. It won't go this way. It is the other way around. This is 2. This is minus 2. And cycle is t by 4. So 360 into 4 is 1440. Yeah. T would mean it completes in 2 pi. And T by 4 means it completes in 8 pi. This is the final answer. Let's try question number. Acceleration, instantaneous rest. Anywhere given distance. Find the time particle comes to less and its distance from O. Take this instant. Distance from O is displacement. Displacement find the total distance traveled. Question 9. A particle moves in a straight line such that its displacement from fixed point O on the line at time t seconds is given by this. 50 e raised to power minus 2t minus e raised to power minus 4t. Find the time when the particle is instantaneously at rest. So we need velocity, and velocity is derivative of displacement 50 stays there. Once as it is into differentiation power, once as it is into differentiation power. 50 minus 2 e raised to minus 2t plus 4 e raised to minus 4t. Particle is at rest, so velocity is 0. 50 goes on the other side, divides, it's 0. Minus 2 e raised to minus 2t plus 4 e raised to minus 4t. 2e minus 2t is equal to 4e minus 4t. 2 1 times, 2 2 times. E raised to minus 2t over e raised to minus 4t is equals to 2. Subtraction e raised to power 2t is equal to 2. 2t is equals to ln 2. T is equal to 1 by 2 ln 2. 9a. 9kt is equals to 1 by 2 ln 2. Find the displacement of the particle when t is equal to 2. Equation is there. Simple substitution. Displacement is 50 e raised to minus 2t minus e minus 4t. Where when time is 2, e raised to minus 4, e raised to minus 8. Using calculator. Zero 0.8990 meters. C part. Find the total distance traveled during the first 2 seconds of motion. First 2 seconds of the motion, I'm again checking if it turns in the first 2 seconds or not. This is the equation of velocity. 50 to e raised to minus 2t plus 4 e raised to minus 4t. Oh, that's already done when the velocity is 0. So let's just check what this value is. That's 1 by 2 ln 2, and that is 0.346. So it does turn. So we can see anything raised by 0, that's 1 minus 1, 0. At time 0, displacement is 0. T is equal to 0, S is equal to 0. So it is at the origin when time is 0. And when time is 1 by 2 ln 2, it turns. So I'm finding the displacement at that point. 50 e raised to minus 2. And this is 0.34657. So I'll use 0.347 rounded to into 0.347 minus e raised to power minus 4 into 0.347 and displacement at that point 50 into e raised to power minus 2 into 0.347 minus e raised to power minus 4 into 347. It's 12.4 and all those lines. It's 12.5 meter. And then total distance was asked for 2 seconds. I'm checking where is it at 2 seconds. At time 0.347, it is at 12.5 meters. 15 to e raised to minus 2 into 2 minus e raised to minus 4 into 2. And getting 0.899. So basically, this is 0.899. So the particle must have traveled all the way here. So the first distance it covered is 12.5. And then this distance is 12.5 minus 0.89. 12.5 plus 12.5 minus 0.899 is 24.101 meters. 24.1 meters. 24.1. Applications of integration in kinematics. We've been doing that already. Velocity is differentiation of displacement, acceleration is differentiation of velocity. A particle moving in straight line passes a fixed point O with velocity 8 meters per second. Its acceleration a meters per second. T seconds after passing O is given by A is equals to 2t plus 1. Equation of acceleration is given. Find the velocity. Now see, this is sort of reverse. We knew displacement time, velocity time, acceleration time. Now from acceleration, he is asking for velocity, so we need to go through integration. Acceleration is already 2t plus 1. So velocity will be acceleration, integration of acceleration, which is 2t plus 1 dt. That's 2t square over 2 plus t plus c, which is simplified to t square plus t plus c. And now the data is given. Particle in a straight line passes a fixed point O with velocity 8. So when it passes the origin, time at that point is 0 and velocity is 8. 0 square plus 0 plus c. So c is equals to 8. Finally, the equation for velocity is t square plus t plus 8. Find the displacement when from origin when t is 3. So we already have the equation of velocity. We integrate it again to find the displacement. So this is t cube over 3 plus t square over 2 plus 8t plus c. And we know at time 0 displacement is 0. Therefore, c is equals to 0. So we now know displacement is t cube over 3 plus t square over 2 plus 8t. And when time is 3, so this is 3 cube over 3 plus 3 square over 2 plus 8 into 3. Three cube by 3 plus 3 square by 2 plus 8 into 3. 37.5 meters. He is having different method, but the answer is same. Why would he find 20? Find the velocity when t is 3. Did I do that? Oh, I skipped that. I just found the equation. So when it is 3, velocity is 3 square plus 3 plus 8. 3 square is 9, 10, 11, 12, 12 and 8 is 20. I was thinking, why is he having one different value? Is A and B part clear? Everything is almost same as in 16.1. Try question number 1, 16.2, question 1.
Okay. A is 16 meters over seconds.
Correct.
B is the time taken before the particle returns to O is 15 seconds. And then C would be the distance traveled by the particle, which would be 38 over 3 meters. And I'll do B and E.
38 over 3, 12.6. That's correct. ABC all correct.
it should be D should be 500 over 3 meters, and E should be 144 meters.
D is correct. 500 by 3. And E, this is 189. Did you check if the particle is turning back anytime between 12 seconds?
I'll check over it.
I'll also do that with you. With equation is given. Yeah, it does. It changes direction at 10. So you have to find distance at 10 also. And then solve.
Okay. I think I'm getting it. Maybe a bit more. But I'm still kind of confused about it.
Here did you? It says in 12 seconds. So what we do is we find at 12 second and we get this point. But what's happening is it was somewhere here at 10 seconds and then it came back. So you actually answered this value. So you already have the equation for displacement, right?
Yes.
Just give me that equation.
Where is it? S equals 5t squared minus 1 over 3t cubed.
That's it.
Yeah, the displacement of the particle.
Okay. So we now need at T10 also. This is 5 into 10 square minus 10 cube over 3 using calculator. getting 500 over 3 at 10. Now at 12 is 144. See, 500 over 3 was approximately equal to 166.6. The particle started at time t is equal to 0, and at time 10 it was somewhere here, which is 166.6 meters away. Then at time 12 it was 144 meters away from the starting point. But the distance traveled is this in green plus this in green. So we already know this full length, that is 166.66 minus 144, and I'm getting 68 over 3, which is 22.66. So the total distance traveled is sum of these two.
Because it's also going back.
Yes. The direct substitution only gives you the displacement, not the distance. This is the distance covered. Question number 2. A particle moving in a straight line passes through the point O. Its velocity is this t seconds after passing through O. So velocity is 32 over t plus 2 whole square. Find the acceleration. So SVA, I need the differentiation. Acceleration is dv over dt. So v is 32 t plus 2 raised to power minus 2 dv by dt is equal to 64 negative 64 t plus 2 minus 3 negative 64 over t plus 2 plus 3 when the particle acceleration when time is 2 minus 64 over 2 plus 2 cube 2 plus 2 is 4 4 cube is 64, that's minus 1 meters per second square. Question 2 a minus 1. Find the expression for displacement SVA. So S is the integration of velocity. B part velocity is 32 t plus 2 raised to a minus 2, and displacement is integration of velocity, that is power plus 1 over new power into differentiation of base, that's just 1 in this case, minus 32 over t plus 2, and there was plus c. Particle moving in a straight line passes fixed point O. So at time 0, displacement is 0, minus 32 by 2 plus c, and 32 by 2 is 16, goes on the other side, positive 16 is equals to c. So displacement is minus 32 over t plus 2 plus 16. Find the expression for displacement, second part. Minus 32, why are we not having c? Minus 32 over t plus particle moving in a straight line passing through a fixed point O. Its velocity v meters per second. At time 0, displacement must be 0. Why is the value c missing? Minus 32 over t plus 2, and c is missing. Particle moving in straight line passes through fixed point O. Time 0. If I am just checking, maybe it's a typing error. We should get 0 displacement at time 0. So this minus 32 by 2 plus 16. Minus 16 plus 16 is 0. This is correct. Final expression done. Then it says find the distance traveled by the particle in third second. That is again 2 and 3, difference of time 2 and time 3. But I need to check if it is turning between that time or not. So equation of velocity is already there. 0 is equals to 32 over t plus 2 squared. So no time, it is not turning between. It is not even turning. So displacement at 3 minus displacement at 2. Minus 32 over t plus 2. 3 plus 2 plus 16 minus 32 over 2 plus 2 plus 16. So that's minus 32 by 5 plus 16 minus minus plus 32 by 4 minus 16. This cancels out. And 32 divided by 4 minus 32 divided by 5 is 1.6. 1.6 meters. 1.6 meters. Hmm. More or less same. Today we'll close this chapter as well. This will be complete. Try question number 5. Is it working?
Yep, I'm just gonna answer all together.
Okay.
So basically, acceleration at t equals ln2 is 119/4, and a displacement at t equals 2 is approximately 109 meters.
Correct. That's correct. So let's have a quick look at the summary if we covered everything. Relationship, displacement, differentiation is velocity, differentiation is acceleration, and reverse is integration. And yeah, that's it. No other summary, practice questions. Only one thing, whenever they ask you about the distance, these equations are for displacement. So we always check if the particle is turning or not between the given time. For example, the question says find the distance traveled till time t is equal to 10, and you find out that it is turning at time 12. So this is outside of the asked question, so no issues. So if they ask you that find distance traveled till time 10 seconds and you see that the particle is turning at 8, now that's a point of concern. We need to check at 8, then we need to check at 10, and then find the distance traveled. Distance traveled will be this and this added together. Or else, when we just substitute 10, it is going to give us this displacement. Here,
Yes.
okay. Now this is done. and we are left with two topics: vectors and chapter 10, 13 and 10. That will be over soon.